Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through polynomials. So what is a polynomial? Well, firstly, a polynomial is a function, so we can use fx notation, but it's a special type of function. It can be written in this form. So what does that mean? Well, each of these a0, a1, a2, they're just constants, and notice that we have x to the power of 0, or x not written there, x to the power 1, x to the power 2, x to the power 3, and so on. What am I saying? I'm saying polynomial is a function if it is just constant term and each other term has a positive integer power of x. So for example, fx equals x to the power of 4 minus 4x squared plus 1. This is a polynomial. So you can see that the powers of x are positive integers and there's a constant term which is okay. It doesn't matter if you skip terms, that there's no x cubed or x term here, because these constants can be 0. So as long as the only powers of x you see written are positive integers, you have a polynomial. So polynomials are very helpful in maths. They just have really nice properties. For example, they have a full domain. You can substitute any value of x into them. Their graphs are continuous. There's no jumps in the graph, unlike we saw graphs of hyperbole, which have jumps. They have asymptotes, no go zones. So that's why polynomials are important. Now this here is still a function, but it does not constitute a polynomial. Why is that? Well, here we do have some integer powers of x, but let's focus on these terms here. See, 1 over x, as you know, is the same as x to the power of minus 1. You also know root x is x to the power of a half. So any expression that has something like this and or something like this will not be a polynomial because the powers of x are not positive integers. Remember, integer is a whole number, so this is not an integer. Negative 1 is an integer, but it's not positive. That's why that's not a polynomial. All right, let's now look at some more definitions that you need to know regarding polynomials. So here I have the polynomial fx equals x cubed minus 3x squared plus 4. It is indeed a polynomial. There's only a constant term and positive integer powers of x. So here are some words you need to know regarding polynomials. So the degree of the polynomial is the highest power of x. So we write it like this, deg for degree and f, because that's the polynomial we're referring to. Highest power of x is 3. So degree 3 polynomials are known as cubics. We've done a lot of work with quadratics, which are always degree 2 polynomials. So the leading term is the term with the highest power of x. So the leading term is this term here, x cubed. The leading coefficient is the coefficient of the leading term. So you know that if coefficient's not written, it's 1. The coefficient of x cubed here, the coefficient of the leading term is 1. So here, the leading term is x cubed. The leading coefficient is 1. So when the leading coefficient, the coefficient of the term with the highest power of x is 1, we say that the polynomial is monic. So this is a monic polynomial because its leading coefficient is 1. If the leading coefficient is not 1, we simply say it's non-monic. And then the constant term of a polynomial is the term with no pronumeral. So here you can see that 4 is the term with no pronumeral. The constant term here is 4. Note, if you have something like x to the power of 4 plus x squared, in this case the constant term would be 0 because x to the power of 4 plus x squared is the same if you add a 0 on it. So no constant term written, it is 0. Now you already know this notation, but let's just have a quick recap of fx is this polynomial here. That means f of negative 1. You rewrite this, but everywhere you see an x, you replace it with a negative 1. So f of negative 1, x is negative 1 here, so it's x cubed minus 3x squared plus 4. and that actually turns out to equal 0. So when you have a number that you can substitute for x to make the polynomial equal 0, we actually call it a root. So -1 is a root of this polynomial. We actually did a lot of work finding the roots of quadratic equations. And of course, roots are the exact same thing as x-intercepts. So we'll see in a few lessons when we graph functions like this, -1 is a root, so -1 is one of the x-intercepts. All right, let's now look at performing operations with polynomials. So here we have two polynomials here. They're clearly polynomials because the only powers of x are positive integer powers. Of course, remember x is the same as x to the power 1. So we're going to look at adding and subtracting polynomials first. Now, it turns out this is easy, and without knowing it, you've actually done it heaps. All you do when you add or subtract polynomials is collect like terms. So I'm just going to look at fx minus gx, this polynomial minus this one. So fx is this, and then of course gx is this. But when I'm subtracting gx, I'm subtracting the whole shebang. You actually need to put brackets around it. And then we just look at like terms. So x cubed minus -2x cubed gives us 3x cubed. Subtract -2 is the same as adding 2. Okay, so I've got rid of those, so I might cross them out just so I can keep track. Now the only other like terms here are 4 and this -2 here. So 4 subtract -2 gives us +6. We leave the -3x squared alone. It has no like terms. And this term becomes -x. So when adding or subtracting polynomials, you always end up getting another polynomial. And to do it, you just add or subtract the like terms. So let's look at this here. This actually says fx times gx. We sometimes use this bullet point here instead of times, so we don't get confused with all the x's. So to multiply polynomials is basic, but it takes quite a long time. When we're multiplying polynomials, we are essentially expanding brackets. So we just know about expanding brackets. So the idea is you have to multiply everything in the first bracket by everything in the second bracket. So we go x cubed times x is x to the power 4. Then we go x cubed times -2x cubed. Then x cubed times -2. And then we look at the next term in the first bracket, -3x squared. I'm going to multiply that by everything inside the second brackets. And then finally, I'm going to take 4 and I'm going to multiply it by each term in the second set of brackets. And then I just need to collect like terms. And here we have our answer after collecting like terms. So when you multiply together 2 degree 3 polynomials, you end up getting a degree 6 polynomial. So multiplying polynomials is easy. It just takes a long time. When you add, subtract, or multiply together 2 polynomials, the result is itself a polynomial. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.